All right, welcome back, Calcsters. Today, again, just to stress, these limits ought to be somewhere. Sine theta over theta as theta goes to 0 is 1, and sine of ax over bx goes to a over b as x goes to 0. These inevitably will show up. Not 100% that we'll get one to show up today, but we're just going to dive right in the deep end with trig stuff. So, here we go. We're going to call this example B, and we're just continuing on. We have been using the squeeze theorem a little bit here. Now, we saw a couple examples with the squeeze theorem. I'll tell you, this one's proof does use the squeeze theorem, the sine x over x that we talked about. There's a better way to do it, and again, I'm shooting for March. Somewhere in March is when we'll see, oh, it's a 10-second problem. Okay, here's the limit that I want us to just jump right in and work through together. I want to take the limit as theta goes to 0 of cos theta minus 1 divided by theta. Ooh, boy. Ooh, isn't that sine? Now, you are thinking of the complements, right? Or the cofunction identities is my guess. We're close. The argument is the issue. Okay, first and foremost, when I talk about the argument of a function, it's what is in parentheses. What do you guys see as the argument of my cosine here? It's just theta. If I wanted it to be all of it and to be theta minus 1, what would I have? I would have parentheses around that entire argument. You are always going to, it's the implication, if there's no parentheses, it's just whatever's connected. If there were parentheses, it would be everything. Okay, so good news or bad news, I don't know where you stand on it. This is not a squeeze rule or a squeeze theorem problem. Now, first step always with limits is to try what? So let's try that on your unit circle, and it's super weird. Remember, theta, this Greek letter right here, represents an angle. Use your hands to point in the direction of an angle of 0 radians or 0 degrees. It's the x-axis. Okay, so looking at this, if you check your unit circle, what's cosine of 0? It's 1. So in the numerator, I'd have 1 minus 1. Oh, no. Over. Oh, why 1? Do you see why it's not 1? Okay. It's indeterminate, right? We can't answer this question. Is there anything obvious to factor? What was the other technique that we saw? Direct sub, factor and divide was the third one. Rationalize. Now, is there a radical here? No, but we're going to use that same approach. Is there a conjugate to cosine of theta minus 1? And rephrasing that, what is the conjugate of cosine theta minus 1? So, not quite, Rafa. Cos theta, then only one little change. Plus 1. Now, this looks and feels a bit like the rationalization. Do you guys agree with that? Okay. What is maybe not as obvious is why would somebody choose to do this? Now, we're going to distribute this numerator. We will do the numerator. Am I going to ever multiply the denominator before I have to? Never. I'm never going to do more work than I absolutely have to. Are you freshmen? So no freshmen dreaming. I want you guys to get to my next line. We still have a limit. We haven't done a limit yet. We just multiplied by a clever choice of 1. And I'm going to just keep working in red. So we now have the limit as theta goes to 0. And I'll do the denominator. Looks like it's theta times cos theta plus 1. What does my numerator turn into, though? Cos theta times cos theta is, so remember the language is weird here, and that only do this really with trig functions. Cos squared theta is how we write it. Oh, it will. So there's my cos squared. Plus cos theta, minus cos theta. Those are gone. Absolutely, JJ. And then we do what at the end? Minus 1. There is something pretty handy about this. So there's a couple different options. For this, there's going to be time after time in math in your life where you're not sure if this is the right choice. Don't be afraid to try stuff. Like, doesn't matter the context. I see a few options. On your trig cheat sheet, here's where my mind is drawn. First thing that I see immediately is cosine squared plus sine squared equals something. This is your Pythagorean identity for the trig stuff. Is there a way that I can write this so it says cos squared minus 1? So subtract the sine squared, subtract the 1. So if I just rearrange, I get cos squared, and there would be a theta in there, minus 1 equals negative sine squared theta. Just by rearranging. Have I lost anybody? Well, this seems like it might work. What am I going to replace my numerator with? Negative sine squared. So let's try that. So now we have the limit as theta goes to 0. My numerator has changed, much like the shade of red I've chosen. Negative sine squared theta over theta times cos theta plus 1. And I will use brackets just to really make it clear that there's my whole argument of the limit. Okay. Well, what should we try? We've rewritten it. It's like we're back at step 1, essentially. What would you suggest we try? Always. Let's try direct sub. What's the sine of theta as theta gets to 0? Or sine 0, if you will. Oh, no. It's still 0 over 0, right? Well, what does it really mean to square sine? It's sine times sine, right? Now, notice, I could rewrite the numerator such that it has two distinct pieces, two factors. It's sine and sine, right? How many distinct pieces does a denominator have? Now, if I want to play around with the fractions to see if something helpful happens, is it true that if I have AB over CD, and this is just me thinking, like here's A times B over C times D, same situation. Can I write this as A over C times B over D if I want? Or could I write it as A over D times, like I can rearrange it as long as all the same pieces are there in the top and bottom, right? Well, let's just try this. If I rewrite this as sine times sine, let's just see what shakes out. The limit as theta approaches 0. We'll do it negative sine theta times sine theta. And I'm going to split this up. Does that still say sine squared if I shoved it all together? Yeah. Now, this technique probably would not become, not something that you would just naturally try. I don't think. Maybe somebody would. It feels unnatural to do this. But let's see if using, I don't know, our notes and stuff, just maybe we can make sense of something else going on. What are my options for the denominator here? Theta or cos theta plus 1, right? It doesn't really matter. They're both the same. Cos theta plus 1. Have I cheated yet? I'm just rearranging. Here, we got a couple different limit properties. I don't want to expand everything out, and I especially don't want you to. Maybe I will. The limit of a product is what we see here. It's just a product of the limits. Where does a constant multiple go when you have a constant multiple? Like limit of kf of x. That constant multiple moved somewhere. To the front. So if I want to, and I don't really want you guys to, you can. I'm going to move this negative sign out to the front of my first limit. So it's negative the limit as theta approaches 0 of sine theta over theta times the limit as theta goes to 0 of sine theta over cos theta plus 1. Before we kick forward, now is the time. If there's anything that you see and you go, I don't know what the heck just happened, please, please, please bring it up. Well, hold on just a second. If you're on a new page of today's notes, I stressed something at the beginning. I said make sure you can see something. What are the two somethings that I stressed I really want you to be able to see today? Oh my gosh! Do we have the limit as theta goes to 0 of sine theta over theta? What is this? That's 1. Holy cow. Okay. So this is negative 1 purely because this was one of those two theorems that we got. Okay, that went to 1. What should we try for the other one? Let's try direct sub. If we try this, what's the sine of 0? Uh-oh. What's the cosine of 0? 1 plus 1? Oh, so check it out. What do we get when we do negative 1 times 0? 0. Abigail, you said negative. Did I lose you? I think you're trying to add is my guess. Cool. Everybody agree it's 0? Okay, I'm going to put one little mark, and I want you guys to dig way back and see if you know. I'm going to put 3 letters, rather, because you guys didn't see this before. If I write these 3 letters at the bottom, what does that indicate we just did? It's the end of a proof. Did that feel like a proof to you guys just now? Not really. To me, it just felt like a problem. Check it out. We get one more important theorem. So here we go. Last super important theorem that we're going to see right here is we get another nice limit. So now we have sine theta over theta as theta goes to 0 is equal to 1. We had sine ax over bx goes to a over b. And now, coincidentally, we get the limit as theta goes to 0 of, we started with cos theta minus 1, all divided by theta, right? Yep. What did we just find this was equal to? 0. This is the third limit that you are going to see over and over and over. Okay. Should we try a harder one? Good. I like the enthusiasm. Now, I do really want to make sure that we're all on the same page with it. The trig stuff, you're rusty. I get it. Some of you learned it differently than others. That's okay. We're just going to practice, and we're going to work through any issues that we might have. Your cheat sheet is going to be fundamental to you working through this stuff and getting it to come back. Let's do one more as a class or with your neighbors for a couple minutes. Was that a sneeze or a cough?
It's a sneeze.
Okay, bless you.
I tried to hold it in.
Don't do that. Just plug your nose. Don't do that. That was a joke. Don't listen to that. All right. I want you guys to play around with this one. This is C, right?
Yeah.
Okay. Just because of plug the nose comment, when I was little, I remember doing like gymnastics for like summer recreation stuff and vividly being embarrassed because whoever it was, probably your guys' age, the instructor I'd guess, we were jumping off the vault into like a pit and we were doing front flips, and every time, because I grew up swimming, I would plug my nose, and I remember them laughing about me plugging my nose. Don't know, something made me think of that just now. No idea what it was, but here we go. Okay, I want you guys to do the limit as x approaches 0. Ooh, this one looks fun. Okay, first of all, it's a lovely fraction. Notice the length of the fraction bar. Okay, in the numerator we have 2x cosecant squared x. 2x cosecant squared x. That's not enough though. Let's add a cosecant x just for good measure. And we're going to divide this bad boy by x cosecant squared x. Now, I'm well aware that somebody doesn't remember it. Cosecant is the reciprocal of another one. Not secant, although I can see why one might think that. Sine. It's weird that it switches from sine to cosecant and cosine to secant, but it's there. I want you guys to try something with the understanding that you might get a big X drawn across your page in a couple minutes, but collaboratively or independently, I want you guys to give this a whirl. Cool. I think that math is more fun when you're not really quite sure where to step. and some of you disagree adamantly, possibly. But let's just see if we treat this like a riddle. Let's just see if this is the right path down to solve. I don't know. There's an analogy in there somewhere. Gosh. Well, I could try direct sub again, but all of a sudden, why is direct sub kind of hard to think about? The 0 in the denominator, one issue. The other issue is that, man, it's kind of hard for me to think about cosecant, right? Like you guys probably as well. I don't have my cosecant values like memorized and stuff. Don't use them. Okay, so let's try it. We divide by 0 over 0. It's actually 1 over 0. It's undefined. Well, what would you guys try? What did we do last time when we had a binomial? Something that might work. We could try to split it. Kind of, yeah. Let's see if it works. I like that idea. So when you say split it, Riley, how would you like me to split this up? I'm not going to write two limits. I'm just going to split it inside. So 2x cosecant x. And then plus 1, I assume, over here. Which one? Ooh, to split them up, it doesn't work quite the same here, does it? Because it's a sum of them. But we can do this if we want. And this would be over x cosecant x as well. Like, that's allowed. I've split it up. Did that do anything for me? Well, let's... Somebody said no right off the bat. Did you check? Because I see that divides out, right? That divides out. Okay, so that's 2 plus... it's still undefined. Maybe. Maybe. Gosh, cosecants aren't really fun to think about. If only there was another trig function that I knew was the same as cosecant. 1 over sine? Huh. Well, let's just try this. This is 2. Right? That first part, the stuff fell out of it. It simplified out pretty nicely. Yay? Okay, plus 1 over x times, what's cosecant again? 1 over sine x? Huh. Well, I think this is going to work. Here's the awesome thing. Completely different than the way that I did it. I'm good with it. Let's just see what shakes out. I need help with this part because my fraction game is not great. Hey, I think it's sine x over x when we clean it up. Would anybody like to see why and how sine x over x spits out here? Okay, let's check it out. This is maybe unintentionally ugly, but is this part right here, and I'm just going to zoom in on that. Is that the same as 1 over x over sine x? And then we do the whoa here. That was a word I was looking for earlier, just for the record, for that opposite reciprocal idea. Yep, Aisha, I am that cool, just so you know. That's it. That's all I did. Well, why do I love what I'm seeing? What's the limit of a constant? So this one, it's like I'm distributing, right? That's a 2. Well, gosh dang it, I don't know this one. We don't have the tools to prove it, or time. Limit as x goes to 0 of sine x over x. Oh. Don't care if it's x or theta, it doesn't matter. It's 1. It's that same theorem. Now here's finally the hard part. What's 2 plus 1? Hey, look at that. This limit is 3. And we're done. Riley, you suggested splitting it up, and then I don't know if it was you that said no or if it was Kalisha, I couldn't tell. Just having an idea is all that it took to get through this problem. Okay. Looking at it, I do want to emphasize here, I'll just show you guys the way that I did this problem. I've made the comment a couple times, you guys love secants and cosecants, right? Nobody likes secants and cosecants. Do you agree it's easier to think about sines and cosines? And last year when we did a bunch of trig, when we encountered something like this, you could either try to deal with it as is, or you can rewrite it using sines and cosines. So check it out. Here's an alternative way to do this. You split it up right off the beginning. Like, let's get rid of all the ugly stuff. Cosecant squared is 1 over sine squared. I just switched them all, and then stuff divides out, but we get almost the exact same work. Slightly different approach, same answer. Cool. I personally prefer the way that we just did it. Rather than changing it to sines and cosines, I think it goes faster, more natural. Everything falls out, even if you don't know what cosecant is. But the big point here, and you're going to hear this over and over, multiple approaches to every single problem that we do. As long as you try something and it's somewhat educated, you're probably going to stumble in the right direction. Cool. All right. So I want you guys to get a little practice with stuff. Can you imagine the graphs of sine and cosine in your head? What do they look like? Waves. They're just waves, right? That's all they are. Imagine the graph of sine and cosine. Can you start and drag your pencil and graph that wave forever and ever and ever and ever and ever? Can you do the same thing with cosine? Which means we just made a determination without having to actually graph them. If I can graph the whole thing without ever picking up my pencil, we're confident in saying sine and cosine are both what? They're continuous functions. Is tangent? Where, and I got a couple questions for you, just as a kind of trig review type thing. So quick, I don't even call it an example, it's just a question. Where is disco? What is disco short for? So I want to know, where is the following or each of the following discontinuous? And let's take a look. On A, I want tan x, or tan theta, if you will. On B, I want you to tell me, based on your unit circle, where cotangent of theta is discontinuous. There's 2 more that are discontinuous. Sine, cosine are good. So we got tangent, cotangent, secant, and cosecant. Talking with your group, your neighbors, I want you to find me, where are these things discontinuous? Okay, again, I want to stress, they pay me the big bucks to help. So if you're looking at this and you're having trouble making sense of your unit circle stuff, let me know. We'll chat about it. This tangent, as just discussed, is undefined when cosine is 0. And we know that that happens when theta is, you started giving me values. Pi halves was the first one, right? And then you had a half a circle and you're 0 again, and another half circle, and you just keep hitting those spots. What's half a circle in radians? It's pi. So how do I say any number of half circles? N pi. These are all the discontinuities of tangent. And realistically, I'm just going to put a note here that says for all n in the set of the integers, so that we don't have to write it 4 times. Any n value that you pick that's an integer, positive or negative, doesn't matter. If you plug in pi halves plus n pi, tangent's undefined. How do we define cotangent? Cosine over sine, or 1 over tangent, but I like cosine over sine. Where is sine undefined? Or 0 rather, sorry. 0, and then again at pi, and 2 pi, 3 pi, 4 pi, 5 pi, negative 50 pi, doesn't matter. Is there an easy way to write that? You could call it 0 plus n pi, but one of those parts doesn't need to be written, I don't think. N pi. Okay. Secant is just 1 over cosine, which, gosh, it's like this is where cosine was undefined. I bet it's the exact same spots. Theta equals n pi. And cosecant is 1 over sine by definition. And we can't divide by 0. This would be at any of the same places as tangent. I should have written these in a different order, but I think we'll be okay. Okay. Tomorrow, you are going to have a ton of time to work on stuff in class. We have 13 minutes right now. I'm going to give you homework 1.4 now, with the understanding that I'm going to add more problems to it tomorrow. Okay. So, cool. we'll get started on it. Homework. I'm going to type it in here so that makes more sense. Right, my internet was dead. Is it still dead? What is going on? We'll see. Nope, it's working. Cool. All right. So today, 9/8. I'll just get the homework and I'll fill in the other stuff. Whoa. Hey, look at that. I was going to give you guys homework last class, but apparently I got distracted by something. Homework 1.4. You will find on page 125. I want you to do problems 1 through 4, and then 9 through 33 odd, skipping number 27. Okay, we will have a bunch of time in class tomorrow as well, so we'll stand by that 45 minutes outside of class hardcore today. We have 10 minutes now to start working on stuff. I will end the video here. You guys can start working, and I'm here to help as needed.